be yes.
All right. Let's start going over these. Couple of quick details. Pay attention to the language because there are a few different ways that we can talk about the dilations. What was the term for a dilation when the image was bigger than the pre-image?
Growth.
Oh, no.
Enlargement.
Say that one more time, Kelsey. It was a stretch because that's what you saw on the calculator and on the page. Yes, it is enlarged, but I need you to notice that when the image is bigger than the pre-image, it's called a what?
A stretch.
A stretch. Okay. When the image is smaller than the pre-image, what is that called?
Compression.
A compression. Are we good with that?
Yes, sir.
All right. From there, I do want to show you a couple of key details. So pay attention to this. So here is TRY and T prime, R prime, Y prime, and we are looking at a compression. And so notice that that image is smaller. But look at the angle measures. What do we see about these angle measures? The angles between the pre-image and the image are what? Congruent. What was done to this length TR to get T prime R prime if my scale factor is 0.5? Multiplied by?
2.
No, it was multiplied by
0.5. Okay. Now, I believe it was Alana, you said something about divided, right? Dude, you're not Alana. I don't need you to comment every time. I'm asking her a question. Did you say something about divide originally? What did you think we were dividing by?
Oh, it.
You're not necessarily wrong. I can't hear her because some of y'all are talking. Please quit. Quit banging things. Pay attention. Alana, what were you saying about division?
It's number 7, right?
I'm just looking at right here for now.
You divide the image divided by the compression.
Oh, you're talking about getting the scale factor.
I'm doing what I'm saying.
Is that what you're trying to talk about?
I don't know.
Okay, so we're going to get to that in a second. What I was going to say is, please, yes.
Divide by 2.
If I look at this 5, could I divide it by 2 to get 2.5?
Yeah.
12 divided by 2 is 6. Well, if I divide by 2, that's the same as multiplying by what?
0.5.
0.5, right? So we want to notice, Anton, it helps to learn when our head is up, okay? It is important to notice that we are still multiplying by the scale factor. Now let's look at the questions that were involved on this paper. So on this page you have a compression. As you move the slider for compression, what is happening?
For compression, the image shrinks.
Okay? So for this part, the image shrinks. Okay, but how do we know how much it shrinks by?
By moving the points.
By sliding into the number.
Okay, you're talking about that sliding, but what is the number that we are sliding it to?
The length.
Say again. That is the scale factor, right? That 0.5 just a second ago that I slid to was the scale factor. So what is actually happening? Yes, and notice what you actually said goes more with what we mean by a compression. The idea of a compression is that the image is shrinking, right? But what's actually happening? Mathematically, how do we go from the pre-image to the image? Ooh, we're going to talk about that in just a second. But just in general, how do we go from a pre-image to the image? We multiply by the what?
Scale factor.
Multiply by the scale factor, right? The image, well, I guess we could say shrinks for both of those. The image shrinks
and then
because we multiplied by the scale factor, right? And
Yeah.
Jalen actually hit on a very, very important idea. What scale factors are shrinks? Values that are less than 1.
Let me see what it is.
With one caveat. If you multiply by a negative, what's that going to do? It's not going to necessarily shrink, but we multiply by negatives in one transformation already. Does anyone remember which transformation we multiply by negatives?
A reflection.
Say it one more time. A reflection. So we don't want to get into the negatives, Matthew, because we're paying attention and learning, right? Nuh-uh. Just, it's my bad, Mr. Kenny. We're just silently and getting a pencil and fixing it. Okay? So we need to notice, do we want to get into the negatives?
No.
No. Because multiplying by a negative is just going to cause what transformation?
Reflection.
Reflection. So we want to. So our scale factor needs to be between 0 and. It needs to be less than 1. So the scale factor needs to be between 0 and
25. 1.
1. If it's between 0 and 1, what's going to happen to the pre-image or the dilation? Stretch or compress? Compress. So pay attention to how the scale factor plays into this difference. If the scale factor is between 0 and 1, what kind of dilation is it?
A rotation. I mean, reflection.
No. If it's between 0 and 1, what type of dilation is it?
Oh, stretch. I mean,
Compression.
I don't know, man.
man, you lose me. Hold on, give me a minute.
Y'all shouting? I'm going to give y'all 10 seconds.
That's not enough time.
Stop and listen. 10 seconds. If the scale factor is between 0 and 1, what type of dilation is it? 10 seconds.
So like.
Yo, what does 10 seconds mean to you?
Be quiet.
Oh.
Alright. I need you to raise your right hand if you think that if it's between 0 and 1, it's a stretch. So right hand if you think it's a stretch, left hand if you think it's a compression. So left hand, right hand.
Wait,
Okay.
that's it for compression or?
If the scale factor is between 0 and 1, right hand for a stretch, left hand for a compression.
Free? I don't know.
Well, look around you, Matthew. What is everyone else saying?
I ain't saying anything, but
Man, I wish you were as funny as you think you
No,
are.
I'm saying
You can
that-
use your eyeballs to figure out what they are indicating. Okay, so if it's between 0 and 1, it's a
Compression.
compression. I want you to think about it. If you multiply by something less than 1, is that number going to get bigger or smaller?
Smaller.
If I take 8 and I multiply by 1/2,
It's smaller.
it's 4, right?
Smaller.
So we got what?
Compression.
Smaller.
Smaller.
Yeah.
So if the scale factor is between 0 and 1, it's
Yeah.
going to
Shrink.
Get
Compress.
smaller.
compress. So it's going to get smaller, it's going to shrink, it's going to compress. If the scale factor is between 0 and 1,
He compresses when
the dilation
compresses when
is a compression.
Wait, so then, okay, so, I don't know if this is.
So when is it a stretch?
A stretch is when it goes, like,
When
higher.
it grows.
When it grows, what scale factor would make it get bigger?
Bigger than 1. A number bigger than 1.
There we go. If the scale factor, by the way, when you have the graphic organizers are built around these questions, so it's really hard to answer or complete the graphic organizers if you don't have notes. If the scale factor is greater than 1, the image stretches. That is one of the most important things to notice Buddy, we're taking these notes on the back side. Or no, this one right here. Okay? This is important to notice about when it's a compression versus when it's a stretch. You've got to recognize when it's a compression and when it's a stretch. Okay? Number 7. Yep, we just finished number 6. We're on number 7. Did a compression act differently than a stretch? I mean, were the pre-image and image angles still congruent? Yes. Were we still multiplying by the scale factor? Yes. So were the compression and compression and stretch different?
Yes. Yes.
They don't behave differently. One just makes it smaller and one makes it bigger. So you would want to make a note on number 7. Hey, it acts exactly the same way. You need to have that note on number 7. On number 7, you need to make the note. Huh?
Yes.
I was getting there, Amari.
When you
On
said-
number 7, you need to make the note that compressions act the same as stretches. They act the same. Give them the slide back. Okay. Way too many of us were struggling on this number 8. If you were struggling on this number 8, you need to make sure that you have this idea down, or that you learn it and understand it. How is the scale factor related to the ratio of the length for the image to the pre-image? How are they related? They are the what?
Scale factor?
I mean, how is the scale factor related to that ratio? The scale factor,
To get the scale factor, you use a fraction. Well, a ratio.
okay,
The length of the image to the.
let's think about relations. They could be greater, they could be less than, they could be equal to, they could be not related at all. Thank you, sir. Is the scale factor greater than the ratio of the lengths? Is it less than? Is it the same as?
It's anything. It can be great, small, the same, anything.
No.
It's a number.
How did we calculate the scale factor?
Oh.
The image divided by the.
I forgot.
Oh, wait, so you're saying we took the length?
I just said that.
Hold on. Hold on. But y'all are missing a key detail here. The length of the image.
Divided by the length of the pre-image.
You wrote that down.
This statement of division is a what?
Scale factor.
It starts with an R.
Oh,
That is a ratio.
I just said that.
Read your statement
I
again.
swear I just said
Read your
that.
statement again.
I said to get the scale factor, we use a fraction, and then I put in parentheses. I made sure I
Okay.
said ratio.
Okay, but here's what you're missing. Okay, hold on, because I'm not completely done. Here's what you're missing. The scale factor is that ratio. This ratio right here
It's
is
the scale
equal
factor.
to.
Equal to the scale factor.
But see, this is why, and that would be 100% correct. But Matthew, this is why you can't say it's greater than or less than. No, the scale factor is that ratio.
Oh, I thought you were talking about.
So, really quickly, does anyone have a guess as to what letter we're going to use for a scale factor?
F.
And if it makes sense for a factor,
Yes.
but also remember, how do we calculate the scale factor? With a what?
Ratio.
Or the ratio. That R is my scale factor.
I got
Not. R stands for scale factor. Terrence, you ain't funny. Write it down if you're gonna try to learn it. Okay?
I'm trying to read it.
So, R stands for scale factor. And this is what I want you to notice. When I say what is the relationship, or how are they related, the scale factor is the ratio. They are the same thing.
So then what's the difference between them?
Nothing!
Nothing. They're the same.
The ratio is how we calculate the scale factor. Now, I will point that out. Well, okay. Let me clarify this. This actually is a good question. This ratio is how we calculate the scale factor.
Take notes.
Terrence, quit. This ratio is how we calculate the scale factor. So the difference between the ratio and the scale factor is this. That's how we calculate the scale factor, but what do we do with the scale factor?
We multiply.
We multiply it by the what? By the what? We multiply the scale factor by something to get the image.
Somebody say it, please.
The scale.
Pre-image.
There you go.
Right? I couldn't hear you. The scale factor is multiplied. Yo, what? How is this helping anyone learn?
It's
It's not. Quit bickering like you're in 4th grade and act like you're in 9th and 11th. Come on.
Come on, kid.
Y'all so crazy. That's crazy. Shut their mouth.
The scale factor is multiplied by the pre-image. I'm teaching. Just stop. So do triangle TRY and T prime, R prime, Y prime have the same orientation? If you don't remember what orientation is, you need to go back to the previous task. How did we define our orientation? The clockwise order of our vertices. Right? Yes? Good job. So was the clockwise order the same?
Yes.
Yes. The clockwise order of the vertices was the same. Okay? Yo, we got like 3 minutes left. Consider the properties of side length, angle measure, perimeter, area, and orientation. Which of these properties, oh, this is not supposed to say translation.
Good afternoon, class. Do you want to be a part of the Black History Month program? The entrance meeting will be held on Monday, November 15th from 3:30 to 4:30 in Mrs. White's room. Happy Black pictures will be taken tomorrow.
Do y'all say dilation? I fixed it.
Picture. Sign
What
up
is
outside
preserved?
208 and bring $25 on picture day.
Yo, sit down.
If you're interested
Hold
in
on.
participating in this year's Dollar Book student,
Angle
please
measure.
see Merit Habitat in the library. If you're interested in Boys and Girls Bowling, please pick up
What else?
Center for
Orientation.
Habitat in the library. Have a terrific Tuesday and go Pats.
Yo, sit down. The angle measure and the orientation are preserved, and I don't think I have it up here, but it is also the shape. So what is not preserved? So length, which is perimeter, and area. We will finish this tomorrow along with starting math literacy. If you are not going to be here tomorrow, for whatever reason, you need to get your math literacy assignment from me today because it is due on Monday. No ands, if, buts about it. Because some people aren't here. Does anyone already know they aren't going to be here tomorrow? Are going to be here. You can go ahead and get the article and the assignment if you want. Anybody else want to go ahead and get this?
See, you right now, finger tip, man. You, man. Hey, I'm just playing. Hey, keep it alone. Do you want to say that later?
I don't know that. Anybody else want to go ahead and get the literacy for all assignment? That is one thing you're definitely missing. All of things tonight. Okay? Awesome, better job today. Oh, thank you. Yeah, that's so good. Alright, Lincoln, can you hit the lights for me, please?